Alright, good morning viewers. Today we'll be looking at physics on scalars and vectors. We have a question on the board. It says, calculate the resultant of 5 coplanar forces of values 10 Newton, 12 Newton, 16 Newton, 20 Newton, 15 Newton acting on an object at O or at 0 as shown in the figure below. Alright, and this is the figure. You see here that there is a force 12 Newton inclined at 50 degrees to the horizontal. There is a force 20 Newton inclined at 40 degrees to the horizontal. There is a force 16 Newton which is on the vertical axis. A force 15 Newton inclined at 30 degrees to the vertical. And then a force 10 Newton directly on the horizontal axis. Alright, let's look at that question. Okay. Now we are going to start with this force, 12 Newton force. 12 Newton force solution, starting with 12 Newton force. Okay, we take this portion out. You have 12 Newton and an angle of 50 degrees towards the horizontal. Okay, now first we must know that here is positive y axis. You are coming downwards, this is negative y, and then if you are going this way, this is positive x. If you are coming this way, this is negative x axis. So you have negative x, and going towards the right is positive x, and then positive y upwards and negative y downwards.
No, it's okay. I'm trying to do that.
Stop talking, keep quiet. Alright, so you have this. Now you will resolve this force to the horizontal axis and you resolve it to the vertical axis. So that this becomes fx here becomes 12 cos 50 degrees, and to the vertical fy becomes 12 sine 50 degrees. Okay, so we have done the resolution to the horizontal. Here is 12 cos 50, and resolving it this way is 12 sine 50 degrees. Of course, I've showed you how we can deduce this in the previous class. How we can deduce this in the previous class, and then this was what I actually did. Supposing you have this, you just take the right angle triangle. You have 50 degrees here, and then this is 12 Newton force. What we need now is the vertical component fy and the horizontal component fx. Okay, so this is angle 90, and of course this side becomes the hypotenuse side, and here is the opposite. This is adjacent. The opposite is the side facing the angle of inclination. But supposing this angle of inclination had to be here becomes the opposite side, and here will be adjacent. Alright, now using your trig ratios, we know that cos 50, or cosine of this angle, becomes the cosine of this angle becomes the adjacent over the hypotenuse, which is the adjacent is fx and the hypotenuse is 12. So fx becomes, when you cross multiply, this is 12 cosine 50, 12 cos 50 degrees. Alright, now that was how we got this place as 12 cos 50 degrees. This is 12 cos 50 degrees. So how did we get the vertical component? This will be sine. The sine of the angle 50, the sine of the angle 50 degrees becomes opposite, the opposite over the hypotenuse. Opposite over the hypotenuse. So now this becomes sine 50, because to opposite is Fy. The hypotenuse is F, which is 12 Newton. So Fy equals to 12 sine 50 degrees. So we have this, that Fy equals to 12 sine 50 degrees. Okay, so that was how we got the vertical component and then the horizontal components. Now, the next thing we'll do is to look at this component 20 Newton force. The 20 Newton force, you extract it out, is where they're having force 20 Newton. Alright. Now, resolving it this way, this is angle 40 degrees to the horizontal. Angle 40 degrees to the horizontal. Now, this is negative x and this is positive y. So, resolve it this way to the vertical axis. This becomes 20 sine 40 degrees, and to the horizontal becomes minus 20 cos 40 degrees. It's minus because it is acting this way towards the left, so that is negative x, and then if it's going upwards, that is positive y. Okay, now we're going to look at this other component. We know that this is 90 degrees. That's right, it's at right angle, perpendicular. So that is, you extract that component out, and you're having 16 Newton, which is going downwards, acting downwards. This is negative y, that is for 16 Newton, inclined at 90 degrees, at right angles. So the fx component becomes minus 16 cos 90, and fy component there becomes minus 16 sine 90 degrees. Minus 16 sine 90 degrees. Okay. Now the next thing you look at is the force 15 Newton. Now how do we do the resolution of the force 15 Newton? It was inclined at 30 degrees to the vertical. Now, you extract that component and you'll be having this. When you extract that component, you have this, force 15 Newton, inclined at 30 degrees to the vertical. It was inclined at 30 degrees to the vertical. Now, let's do the resolution. Here you have minus y, and over here you're having plus x. Okay, so resolving it to the horizontal axis, this is 15 sine 30 degrees. Yes, you know, if the angle were to be inclined here, let's say for instance this angle was inclined here, this becomes, if it were to be inclined here, this component will be cos 15 cos 30. But then the angle was not inclined towards the horizontal, rather it was inclined towards the vertical. The angle was inclined towards the vertical. So since it was inclined towards the vertical, this component becomes 15 sine 30 degrees. And here becomes, it's coming downwards, so it will be minus 15 cos 30 degrees. Okay. So that is what we have. So it's going this way towards the right. It's 15 sine 30. Coming downwards, you have minus 15 cos 30 degrees. Why? Because the angle was inclined this way. You know, if you extract this component out, okay, this is what I mean. When you extract this component out, you have something like this. subtracting that component, you are having something like this, 30 degrees, and here this component is over here, you have 15 Newton. So we are meant to resolve the force, resolve it horizontally and vertically, here and here. So what then do you have? This now becomes it is coming down to be negative. So here is your opposite side, and here the longest side is the hypotenuse, and here is the adjacent. Now I explained earlier that for a right angle triangle, the side that faces the angle of inclination is the opposite side. For a right angle triangle, the side facing the angle of inclination, like this side, is facing this inclination angle. So this becomes the opposite. But supposing this angle were to be here, supposing this angle of inclination were to be here, here becomes the opposite, and here will be adjacent. So that's the idea, that's the concept. So since this angle of inclination is here, the inclination angle is here, now you find out that this component then becomes the opposite. Why? The inclination angle is here, and the side facing the inclination angle is the opposite side. Now you will say that cos 30 degrees will be adjacent over hypotenuse. So cos 30 will be equal to, the adjacent side is this component, which is Fy. The opposite here is Fx. So Fy will be over hypotenuse is 15 Newton, cross multiply, this will multiply this. So Fy then equals to 15 cos 30 degrees. 15 cos 30 degrees. Alright, now how do we look for the horizontal component Fx? We have here as 15 cos 30 degrees by virtue of the inclination angle 30. Now the horizontal component, you see that sine 30 degrees is opposite over hypotenuse, which is the opposite now is Fx. The opposite components, opposite side is Fx, and the hypotenuse is 15. Now if you cross multiply, this will multiply this, and you'll be having the horizontal component Fx as 15 sine 30 degrees. Now, I believe at this point you understood how we arrived at our answer. The horizontal component here as 15 sine 30, and the vertical component as 15 cos 30 degrees. Of course it is negative. Why? Because it is acting downwards. It's acting vertically downwards, so we have the negative sign. Right, so the bone of contention is this, that whenever this angle of inclination is inclined towards the horizontal component, certainly that horizontal component becomes the cosine of the angle, and the vertical becomes the sine of the angle. But whenever the inclination angle is inclined towards the vertical, this is the vertical line, it is inclined towards the vertical, then the vertical component becomes the cosine of the angle, and the horizontal component becomes the sine of the angle. It depends on the positioning of this angle of inclination. So take note. If the angle of inclination is inclined towards the horizontal, this x-axis becomes what? The cosine of the angle, and the y-axis becomes sine of the angle. And if the angle of inclination is inclined towards the vertical, then certainly the vertical component becomes the cosine of the angle, and the horizontal component becomes the sine of the angle. Okay. Now we have done the necessary resolution. The last one there is the 10 Newton force. The 10 Newton force that acts directly on the x-axis. Force 10 Newton. Then it is going to the positive x-axis. And what do you do there? It is going towards the positive x-axis. Right. Then what then happens here? If you look at this component, you see that Fx will be equal to 10 cos 0 degrees, and Fy here will be 10 sine 0 degrees. Of course, we know that cos 0 is 1. Then that means that certainly this will be on the horizontal axis. and sine 0 is nothing, 0. And then when you look at this one, the idea is this: sine 90 degrees is 1. Of course, this will be on the vertical axis, the negative vertical axis. So this is minus 16 sine 90, sine 90 is 1, so this works out. But cos 90 is 0. When you use your scientific calculator, you confirm that. And cos 90 is 0, so everything cancels out. But the vertical axis, Fy, we surely have this component 16 Newton acting vertically downwards, so it becomes negative. Alright, yes, we are solving with our sign conventions. Now we are going to represent this on a table, a simple table. Please look at a diagrammatical representation on a table. This is what you'll be having. The representation of this diagram on a table of values. We'll be having fx, f, then theta, then fx and fy. So f is the force in newtons, the force measured in newtons, and theta is the angle of inclination. So for the first force, we have 12 Newton. The angle was 50 degrees. And the horizontal component was 12 cos 50. Was 12 cos 50 degrees. The vertical component is 12 sine 50 degrees. It's 12 sine 50 degrees. Alright. Now we'll look at the next one. The next force there is 20 Newton force. The 20 Newton force. So for the 20 Newton force is what we're having. 20 Newton force. The angle was 40 degrees. And the horizontal component we had was minus 20 cos 40. And the vertical component was 20 sine 40 degrees. Now the next force we'll look at there is 16 Newton. 16 Newton. Yes, 16 Newton force. The x-axis there, sorry, the angle is 90 degrees. Angle 90. That is this angle at right angle, or it says perpendicular. Now, this is minus 16 cos 90 degrees. And this is minus 16 sine 90 degrees. Alright, then the next one we'll look at there is 15 Newton force. The 15 Newton force has an angle of 30 degrees inclined to the vertical. Has an angle of 30 degrees inclined to the vertical. So when we resolve to the x-axis, we had 15 sine 30. And resolving to the y-axis, we had minus 15 cos 30 degrees. Now the next one we'll look at is the 10 Newton force. The 10 Newton force has an angle of 0 degrees. Of course, that's on the x-axis, and you know your number line. This is 0 degrees. So the x component there is 10 cos 0, and the y component is 10 sine 0 degrees. Okay. Now we have gotten the table of values. This is exactly what we want. Then we can further do justice to it by taking the summation of forces acting on the x-axis. The summation of forces acting on the x-axis, which is sigma fx, and then we will later take the summation of forces acting on the y-axis, which is sigma fy. Alright, let's do that. Let's do that quickly. Okay. And we'll be having Alright, so we'll take the summation of forces. The summation of forces on the x-axis. Summation of forces on the x-axis. Of course, we know that the x-axis is also called the horizontal component or the abscissa. The x-axis is called horizontal component or the abscissa, as on any graph sheet. And the y-axis is called the vertical component or the ordinate. Alright, now this becomes sigma fx. Sigma fx will be equal to, on that other board there, we have 12 cos 50 degrees plus minus 20 cos 40 degrees, 40 plus we have minus 16 cos 60 degrees, sorry, cos 90 degrees. Then plus 15 sine 30 degrees plus 10 cos 0 degrees. Okay, now this then becomes 12 cos 50 degrees, plus times minus is minus, so you have minus 20 cos 40 degrees, plus times minus is minus, you have minus 16 cos 90 degrees plus 15 sine 30 degrees plus 10 cos 0 degrees. So this then will be equal to 12 into bracket cos 50. Using your calculator, you obtain the value of cos 50, and cos 50 is 0.643 minus 20 to bracket cos 40 is 0.766 minus 16 to bracket cos 0 is 0 plus 15 sine 30 is 0.5, that is half, plus 10 cos 0 is 1. Okay, and which when you multiply, you get further values. When you multiply, you get further values. So 12 times 0.643 gives us 7.716 minus 20 times 0.766 is 15.32. And then 16 times 0 is 0. Of course, anything that multiplies 0 is 0. Then 15 times 0.5 is 7.5. That is half of 15. And then 10 times 1 is 10. When you do your further arithmetics, 7.716 minus 15.32 minus 0 plus 7.5 plus 10 finally gives us 9.896 newtons. So sigma fx is 9.896 newton. Now the next thing you obtain is the summation of forces. The summation of forces. The summation of forces on the y-axis. Summation of forces on the y-axis. Now let us look at the summation of forces on the vertical component or the ordinate. Now sigma fy will be equal to, over there on the board there we have 12 sine 50 degrees plus 20 sine 40 degrees plus minus 16 sine 90 degrees plus minus 15 cos 30 degrees plus 10 sine 0 degrees. Okay, so now this becomes 12 sine 50 plus 20 sine 40 degrees, plus times minus is minus, that is minus 16 sine 90 degrees, plus times minus is minus, that's minus 15 cos 30 degrees, plus 10 sine 0 degrees. So this will be equals to 12 into brackets sine 50. What is the value of sine 50? Sine 50 is 0.766 plus 20 into bracket sine 40 is 0.643 minus 16, sine 90 is 1, minus 15, cos 30 0.866, plus 10 sine 0 is 0. Sine 0 is 0, so that component go out. So you multiply this, what we're having 9.192, that's this times this, 12 times 0.766 is 9.192 plus 20 times 0.643 gives us 12.86. 16 times 1 is 16, and then 15 times 0.866 is 12.99. Finally, 10 times 0 is 0. Any number that multiplies 0 gives you 0. So sigma Fy then becomes what? Sigma Fy finally becomes, you have sigma Fy will be equal to, and the summation of forces on the y-axis becomes what? And you add everything here, gives you minus 6.938. Minus 6.938. Okay, so what else do you do? Hence you have gotten the value of sigma fx and sigma fy. We have obtained the summation of forces on the x-axis as 9.896, and then we have obtained the summation of forces on the y-axis as minus 6.938. You then draw the force diagram, and with the aid of the force diagram you can obtain the magnitude of the resultant and also the direction. And once you have gotten that, you are done with the solving. Let's proceed further. Now this becomes let's look at the force diagram. Let's look at the force diagram there. This is positive y, negative y, positive x, and negative x. Okay. Now we know that sigma fx is positive, so you go this way, and we also know that sigma fy is negative, so you come downwards this way. Okay, it's negative, so you come downwards like this. You have that sigma fy is so you leave that negative sign. This is 6.938 Newton, and sigma fx is 9.896 Newton. Okay, so this is what you need. This is called the angle of inclination alpha, and here is called sigma f, summation of forces. Okay, so that is what you need. Okay, so you can then solve to obtain this. When you extract this component of the triangle out, extract this component of the triangle, of course you know this is 90 degrees. So we extract this component of the triangle, and you'll be having this, having a right angle triangle, angle 90, the inclination angle, this is the direction, and sigma f is the magnitude of the resultant. Of sigma fx as 9.896 Newton, and sigma fy as 6.938 Newton. Okay, so from Pythagoras rule, that the hypotenuse square is equal to opposite square plus adjacent square. Okay, the hypotenuse, the opposite, the adjacent. So we can say that that sigma f square equals to, the opposite is this, sigma fy all square, plus adjacent is what? Sigma fx all square, which you can rearrange as sigma f equal to all square equals to sigma fx all square plus what? Sigma fy all square. Okay, now take square root of both sides. You have that sigma f will be equal to the square root of sigma fx all square plus sigma fy all square. So when we take the square root of both sides, this becomes this. We were able to eliminate this by taking square root of both sides. This is sigma f all square raised to the power of half equals to sigma fx square plus sigma fy square all raised to the power of half. So this will eliminate this, and if a number is raised to the power of half, that is square root of the number. So we arrived at that, sigma fx plus sigma fy all square. That's the square root of the number when it is raised to the power of half. If it is raised to the power 1/3, that is the cube root of that number. That's it, by the way. So we have the sigma f. We have that sigma f equals to square root of sigma fx is 9.896 raised to the power of 2 plus sigma fy is 6.938 all raised to the power of 2. Okay, so this then gives us when you add them, use your calculator, the square of this plus the square of this will give us 146.06666, and the square root of the answer will be 12.09 Newton. How do you find the direction? To obtain the direction alpha, you say tan alpha will be equals to the opposite side divided by the adjacent. Of course, we have a good knowledge of trigonometric ratios, and we know that in trig ratios, so katwa, that when you're looking at the tangent of an angle is the opposite side divided by the adjacent side. Okay, so that's opposite divided by adjacent. So this becomes the opposite side is sigma fy, and the adjacent side is sigma fx. And sigma fy is what? 6.938 divided by sigma fy is 9.896. When you divide, it gives you 0.7011. Now we'll look for the tan inverse of 0.7011. The tan inverse of 0.7011. So if tan alpha,
Okay, let's bring it down.
if tan alpha is equal to 0.7011, alpha itself will be tan inverse of 0.7011. So alpha is equal to tan inverse of 0.7011 is 35.03 degrees. 35.03 degrees. So it then means we have obtained the magnitude of the resultant as 12.09 Newton, and the direction is 35.03. This means that therefore the magnitude of the resultant, which is sigma f, is 12.09 Newton, and the direction of the resultant is 35.03 degrees. That is to 2 decimal places. There's 2 decimal places and 4 significant figures, and this one is to 2 decimal places as well. This is the magnitude of the resultant, and this is the direction. Alright, we have come to the end of the study for today. Please don't forget to like this video, drop your comments, and also subscribe for more educative videos in subsequent time. Thank you.